My name's Anthony. I'm the technical lead for the Open Ecoacoustics project. And today we're going to give you a little bit of an introduction to our platform and tell you what we do, why we do it, how you can do things too, and why it's relevant for this webinar. So, who are we and what do we do? We are Open Ecoacoustics. We have emerged from the QT Ecoacoustics research group. And in our current form, we're a co-investment partnership with the ARDC, and we're in the Planet Research Data Commons theme. We aim to be the kind of default way people store their ecoacoustics data and analyze it within Australia. And there are other Planet RDC programs that work with other different types of data. So if you are interested in camera trap data, check out WildObs. It's another Planet RDC program. And if you're interested in modeling and analytics, check out EcoCommons and Biosecurity Commons. What do we actually do? Well, we build software like the Acoustic Workbench, which is our data management platform. We build species recognizers, we build metadata tools for working with audio data, and we build graphical components for working with ecoacoustics data on websites. We also run that software, and we do that in a couple different services that we run. EcoSounds is a place where you can upload and share your own audio data. The ATO is a national fixed experiment where all the data is open source, but it doesn't accept contributions from other people. There's about 300 years of open source data on the ATO that's publicly accessible from right around Australia. And Call Detective is our citizen science initiative. We also do training and community development. So we run workshops, we write documentation, and we participate in webinars like this one. On our training materials, they're all on our website. They're all open source and they're community editable. So if you want to learn about something that you don't know how to do, check out our resources. If there's something there that is not covered, or you have something that you want to be covered as well, you can contribute. If you're not sure how, reach out and we'll help you add the material to the website. We're mainly going to talk about our data management platform today, and that powers EcoSounds and the A2O. So it's a website, it's designed to manage ecoacoustic data, and it's open to the public. EcoSounds in particular is where you can upload your data. When you create a project, you own the data and you control access to the data. So you can have private projects or public ones, and you can give individual users access to your project. You can, of course, upload data and download it and share it with other people. And you can import, create, and verify annotations. So that's labeled sections of an audio recording, typically where fauna are vocalizing. So you label a bird call, that's an annotation. And you can run a bunch of analyses automatically on the platform. For those that are more technically minded, we have an API. So if our website doesn't do what you need it to do, there's a fair chance that you can use the API to do something new and interesting. If that sounds like a problem you have, come talk to us and we'd love to help you with that. The software itself is generic and open source, as per our name. And it is a data management platform, so it's kind of ideal for an ecologist or a data officer or someone managing data. So we want our platform for storing audio data to be the national platform for ecoacoustics, the default choice. And we have some work to do to get there, but one of the ways we want to achieve that goal is making sure we have an end-to-end workflow for processing and working with ecoacoustic data. Before we talk about the workflows that we do have, I was just going to give you kind of a broad overview of our project, a little bit of an idea of the scope of it. We have data from right around the world, actually. in about 6,000 locations, and we've just topped a petabyte of audio data. That's about 700 years of data recording continuously, and we've got 9 million or so annotations, and 42,000 of which are verified, and that's a number that we're going to try and increase with those verifications. So if you do decide you want to share or host data with us, the first step in the workflow is to create a project. So anyone can create a project. You can choose the permissions for that project, private, public, and you can choose the licensing. Once you create a project, you can organize it into regions, areas, and those regions have sites or points, even depending on the terminology you like to use, and those are where there are sensors on the ground. We have a remote upload tool, and it fully supports you uploading your own data from your own site. You don't have to send it to us, but Australia's got some classically bad internet, so we still regularly accept hard drives and SD cards that people ship to us. Our upload tool, though, supports terabytes of data at a time, thousands and thousands of files, and it works with standard transfer software called SFTP. One of the really nice things about our upload process is that it can validate and fix common problems with audio data that you upload. Like it will detect duplicates and won't let you upload them, it won't let you upload overlaps, and it can even fix common problems that sensors have when they produce audio files, so it can repair data too. After it's uploaded, generally you want to analyze it. So this is a system we've been building over the last 2 or 3 years. We're very lucky to be hosted at an institution that has a very powerful cluster, a supercomputer. So we have 2,000 kind of computers we can kind of tap for their resources. And at the moment, we're mainly focusing on running BirdNet and perch embeddings, as well as various recognizers, including the BirdNet classifier and different custom recognizers. The analysis system is designed to be automated, and one of the cool things that happen is when you upload your data, it can be scheduled to be analyzed, and that's great. Now, my colleague Phil, who's in charge of building recognizers here at Open Ecoacoustics, is going to talk now about how we build custom recognizers as part of this analysis workflow.
So, as I mentioned, the analysis part of this greater workflow has lately been focused a lot on building call recognizers and running those call recognizers. And I've been using embeddings, perch embeddings, BirdNet embeddings to do this. And I've we've built a platform which has evolved over the last couple of years to do that. And this platform is now sort of being formed into a way that ecologists can use it directly. So without having to go through or ask someone else to build the recognizer to build it themselves. And it uses ecosounds via the API, but it's not part of ecosounds. So there's 2 main parts to it. There's a platform for building the recognizer, and then that interacts with ecosounds pulling annotations. So there's, as in short segments of audio that are labeled with your species of interest, like or call type, pulls audio so that you can see spectrograms and verify detections within the recognizer building tool, and most importantly, pulls these perch or BirdNet embeddings, and I'm going to get into what those are exactly in a couple of slides. Then that platform outputs a small file, a call recognizer that's just a JSON file, and that can then be run on a separate tool, again interacting with ecosounds via the API, pulling these embeddings, hundreds of thousands of files, of audio files of embeddings if needed. And then the detections are then ingested back into the ecosounds database, again via the API. Next slide. What that looks like in a little bit more detail. So this platform for building the recognizer uses something called agile modeling, which is kind of like an active learning, the machine learning workflow. So the first thing is that the embeddings are generated on ecosounds. And so like we don't have to do that as when we're building the recognizer. That's done automatically, and those are available via the API. And that's a really great time saver and headache saver, because it can be a bit of a pain to get things set up in order to generate those Perch or BirdNet embeddings. But also it can take a long time to compute them. And it's really great having them available on ecosounds so that we can just request them via audio recording ID. And those are, so what that essentially means is that the entire set of audio that you're working with is segmented into 5-second segments, and each of those is represented by a thing called an embedding. So we pull those down for the audio of interest, and we can provide then a 5-second audio clip of this target species that we're wanting to build a recognizer for. And then there's this search through the embeddings phase, so it can compare embeddings of your labeled example with all of your unlabeled examples and give you the most similar results. You can then look through those, verify them as true or false of your target species, and then you'll have a labeled set to train a linear classifier. And then that linear classifier is used again to search through your unlabeled audio set and verify those and refine the classifier little by little. And this cycle of searching, verifying, training is active learning or agile modeling. We also pull the annotations that are already on ecosounds via the API to add to the training examples. And then at the end, the whole thing is available as a classifier. And it's a really small, because it's a linear classifier, it's a very small artifact. It's just a text file, a couple of kilobytes. And that's what's produced. Next slide. So all of this has been talking a lot about embeddings. So I'll very quickly go over what that actually means in case it's an unfamiliar term to you. So Perch is a big convolutional neural network that's been trained on lots and lots of audio data. It's produced by Google DeepMind. BirdNet is another famous one. Again, convolutional neural network trained on lots and lots and lots of examples, millions of examples. And these transform via this neural network raw audio into a much smaller representation. So 5-second segment of audio is reduced to just a list of between 1,000 and 2,000 numbers long. And those things are called embeddings. And the way that it's trained, it's trained such that these embeddings can be compared with each other. A distance between them can be meaningful, and things that are close together in that embedding space are likely to be similar call types. So those can be thought about as coordinates in a high-dimensional space, which is hard to visualize, but it's sort of similar to coordinates on a two-dimensional space, i.e. like a map. So the picture that you can see here is sort of a map of where these embeddings fall. So the job of the embedding is to position things on a map so that similar things are near each other. And when you have labels for some of those things, the classifier can find a line that it can draw between the different classes, so that then when you have a new example, you can place it somewhere on that map, and based on where it is in relation to the line that your classifier's positioned in that map, you can assign a class or a label to it. So that's what embeddings are in a nutshell. Next slide. So that's what I've spoken about so far is sort of the concept, the general concept of how the workflow works in a diagram, but what does it actually look like when you're using it? So we have a user interface where you can add input all of the parameters and choices that you can make. You can explore the data within the embeddings, two-dimensional projection of the embedding space, which is what is shown here on this slide. Can verify things. So it doesn't use any, you don't need to do any coding or anything like that. All of the actual coding has been sort of hidden behind this user interface, but this is still just a Python package that you can install and run, which can still be a bit of a challenge. So we do offer it as a hosted Jupyter, in a hosted Jupyter environment. So it's not public, as in it's not available for anyone to go to and just sign up to. We sort of have to set it up for you at this stage, but that's something that we can do so that you can use this platform to then start running your recognizers. Next slide. So the second part was to run the recognizer over all of the unlabeled data. And once you do that, you might get thousands, tens of thousands, hundreds of thousands of detections. And most people want to look through at least some of them and verify them and label them as true detections or false positives. EcoSounds has a really, really good interface for doing this, where grids of spectrograms can be viewed many at a time. And depending on sort of how many true and false positives and the difficulty of you visually recognizing whether it's true or false positive, you can get through these verification tasks very, very fast using this high throughput user interface. For example, we've had some examples where 2,000 or 3,000 detections have been verified within an hour or two, sitting and just clicking through because of the keyboard shortcuts, because it's been set up for using quickly. And then once that's done, you've got some verified detections, and you probably want to see statistics about them, aggregate them in certain ways. So I'll hand back over to Anthony for explaining the next part, which is the reporting.
Thanks, Phil. Yeah, so we expect most scientists are going to want to download annotation data, observations themselves, and formulate it into some kind of complex analysis. But there are many people who don't want to do that. So one of the things we've been building this year are the concept of reports. And these are basic overviews of the data that we have in the EcoSounds for your project. So these are a summary of where your data is, what's been analyzed, and what species have been detected with what verification rates. And we expect these reports to be useful for things like land managers or project managers that really don't want to do that much advanced analysis themselves. One of the other reports we're building right now, this is kind of a beta we should have released next year, is just a map that shows where events are and when they've been detected. So this is just fake data. Don't worry, there's no yellow belly gliders being kept inside that block at QUT. But it just shows you where events are, at what sites, the counts, and the different scores for the detections. This kind of interactive map is going to be really useful for just kind of exposing what is there and what isn't. You can apply filters, look at the results, and see the different spectrograms associated with each of them. Just a really nice way to see and validate visually where your data is. So this will be coming next year. The last step in our workflow, and one of the most important ones, is exporting your data, which most scientists are going to want to do. So you can download your data again if you need, or that's a great way of sharing your data with other people. You upload it and then they can download it elsewhere. You can also download all your observations, your annotations, including with verification data if they've gone through a verification step. And some features we're going to start building or look at to build next year include kind of bulk snippet download, so you can download 3 or 5 second segments centered around your observations for further training rounds, or bulk analysis result download. And both of those functions are already available through our API if you want to automate that yourself. One of the most exciting aspects of the export part of our workflow will be exporting our observations, our annotations, in the camera trap DP bioacoustics adaptation format. So that adaptation is currently being spearheaded by some people in Europe, and they're taking an existing standard for exporting observations for camera traps, and they're adapting it to work with acoustic data. So we'll build that format into our system, which will make our data interoperable. And then ALA have already been working on accepting camera trap DP standards, and this will be really exciting because it means if you choose, you can export your annotations and observations to ALA. And once they're at ALA, we have this fantastic resource where you have a mix of human observations, camera trap observations, and ecoacoustics observations in one platform where you can do meta-analysis. Sorry. Another thing we're doing at the moment is what we call microsites, and this is a spoiler for what Rob's going to talk about later. But the simple tagline here is if you have a lot of data with a lot of annotations and you need some verifications, and you have a group of citizen experts or scientists or an engaged group of users, and you want them to help you verify what has been detected from a recognizer, then talk to us and we might be able to build you a microsite for your project. The idea is they're very simple, 2-page website designed for engagement. We've got more work coming up, and these are important features that will help make our platform a great data management platform for ecoacoustics. So things like persistent identifiers, so you get like a DOI for your data when you upload it, augmented integration for automatic citation generation and metrics, AAF integration for like one-click login, and an alternate upload mechanism that works just via a web browser. So our government users don't have to install any additional software to do transfers. That's all we have for today. We're happy to answer questions either now or later, but I think the thing I really want to do is encourage you to reach out. If you think you could use any part of our platform, or you have data that you want to upload or just store somewhere or share, reach out to us and we can probably accommodate to you. So thank you very much for listening.